Physics students, good afternoon. In this video today, we're going to be looking at the idea of static equilibrium and how using that idea of static equilibrium can help us look at the forces acting on an object, specifically a bridge. Now, this problem is geared towards, or the problem we're going to work through is very similar to what you'll see in problem 9 on homework 12 over the ideas of torque and static equilibrium. Now, problem 9 is the second of a two-part problem, obviously starting in problem 8. So if you haven't solved problem 8, go back, watch the video, make sure you feel comfortable with what we did in part 8, because really part 9 is just a small continuation of what we did in 8. So, just to refresh you all on what we're doing here, in this problem, we have a bridge, and we're told that each end of the bridge is used to support the forces that are acting on the bridge. And those supports are referred to as support A on the left-hand side and support B on the right-hand side. We're told as well that there is a truck on the bridge a certain distance away from point A. It's about 15 meters. I'm not going to redraw that to keep our picture a little bit cleaner here. Now in this problem, we're asked to figure out, well, what is the force of support? It's referred to as a normal force at point A. Now, in order to get an idea of what's going on at point A in terms of a force, we need to look at the other forces that we have involved here. Now, for the previous problem, we said that we have a force of gravity acting on our truck, and we actually were able to solve for that force of gravity. And we're told the truck's mass is 38,000 kilograms. So taking that value of mass, 38,000, and multiplying by acceleration due to gravity, we get right at 372,400 newtons. Seems like a large number, but remember we're dealing with a big force here. Or excuse me, we're dealing with a big mass here, which means our force is going to be high. And we're also aware that the bridge itself has mass. Just like any object that's made up of matter. Because it has mass, it's going to be worked on, pulled on, by a force of gravity. We said that that force of gravity acts at the object's center of mass, its center point, which is right in the middle of the bridge. Now the bridge itself has a mass of 63,000 kilograms. So when we take that value and multiply by acceleration due to gravity, 9.8, we get 617,400 newtons. Now in part 8, the previous problem associated with this two-part scenario, we also solved for the force at point B. And we're going to take that number, which was right at about, come all the way down here, 532,683. And we're going to use that now in this scenario. 532,683 newtons. Now we're asked here to solve for, well, what is the force of support at point A, the left side of our bridge? Now here, because we have 3 of the forces involved in our system, and we're looking for the 4th, we can use our idea of sum of forces. Now static equilibrium means that the sum of forces must be equal to 0. It also means the sum of torques equals 0, but we already used that in the previous example, so now we can just look directly at the forces. So if I look up here, I have force A, we would say that's positive, it's going up, and force B, also positive, going up. So we'll say FA plus FB, which was our, and we'll just plug in our number directly, 532,683. Now we're going to subtract our two forces going downward, because we would say they're negative according to our convention. So minus 617,400 newtons minus 372,400 newtons. And all of those summed up must come out to 0. So really all I'm going to do now is I'm going to add these forces up. And we'll go 532,683 minus 617,400 minus 372,400. So what that gives us is this. FA minus 457,117 newtons must equal 0. Okay, so what that tells us is now we have a way to solve for FA by itself. Just going to add this 457,000 number over to the other side of our equation, And we'll be left with a value of FA equal to 457,117 newtons. Effectively, our way of making sure all the forces balance out to zero, meeting our condition for static equilibrium. So when we check our answer, I get 457,110, okay, 457,117, a little bit of rounding in there that we did throughout the problem, but for the most part, we're right on track. So, in this problem, and you do not need to go through and use that idea of sum of torques again. We could, if we wanted to, but again, it's just going to be a whole lot more work that we don't need to do, which is why solving part 8 is very important for us to get to part 9. So, hopefully this gets us going in the right direction for this problem. Hey, if you have any questions, don't hesitate to let me know. And good luck.